for each project. Today itself, around 12 kickoff sessions for 12 projects is planned. In the next 4 days approx, we'll have the kickoff of every project that is in the ecosystem right now of TSOC. And after that, we are going to follow it up with the mentor sessions. Most of the mentor sessions, pretty much all of them, are going to be at the time of 8:30 in the night. 8:30 to 9:30 is one project, and 9:30 to 10:30 is another project. That's going to be pretty much it, because these mentors are from, most of them are from Silicon Valley or USA, around that region. So it's their morning time and our night time. So this is how we are managing it. The sessions with me and other people from India are in the morning, and the sessions with the international folks are mainly in the night. So that's how it's going to be. Now, week one, what we did was the program introduction, right? We did the orientation and gave you the learning tools for you to be learning on Discord, how to do GitHub, and learn JavaScript, and learn blockchain development course, do the certification, basic things that are required for you to be starting to contributing on the different projects. We are going to have the kickoff meetings and overview of the problem statement just today and a few days, as I told you. That's basically the week one, the phase one of the project, which we have almost finished. Now, this week 2 to 3, week 2, at the end of this week 2, we are going to have the product requirement document with a deep requirement analysis of what the problem statement is about, right? The team, you will be having a bonding session, you will bond together, you will have some leader representative appointed, you'll have the program coordinator among you appointed. This is going to set the entire structure of the project for you this week. So what you have to do is, you will get the problem statement in a kickoff meeting with me. I'll be personally kicking off every single project. With that, you will get the problem statement and what it is all about. And then you have to then make a document. We'll share a template with you as well of what are the things you have to do. But you have to make a Google Doc together collaboratively for analyzing the problem, breaking it down into multiple solution pieces, which are the modules. And then you're going to select the solution you need and present it. Then first, let me just give a brief overview of all the phases of the project of entire 3 months, and then let's go into the exact structure of that document. So next week after that, we'll have the design phase, in which we'll design the backend architecture of the database we are going to use, the deployment, where we are going to do the deployment, and have the interface designed, a low fidelity interface it's called, when we have some rough sketch of what the website or the web design is going to look like, where the button is going to be. That is what a utility design is called. So you are going to brainstorm and make that happen. You will keep receiving feedback and revising the design as necessary. But at the end of week 4, we need to have that very concrete and fixed. The database columns and everything is also fixed. The table architecture is also fixed. Then we can move on to the core development phase, which is from week 5 to week 10, in which we implement everything we have planned in the roadmap. At the end of this next week, we are going to have a breakdown of all the issues and modules in each GitHub project. So that is what we're going to achieve. All the issues are going to be achieved. Each one of you will get a chance to be contributing. You'll be able to fix an issue and raise the pull request and merge your code and get your points, and that's how it's going to be. So midterm evaluation happens at the mid approximately of this week 5 to 10, in which we check on with each team where they are with their respective projects. And at the end of that itself, we have some people also coming in from each project to the Citadel to represent their project, and we'll see how we go from there. Next week after that is week 11, that we are ending the last phases of the project. Each module you must have integrated already. This is where we do the unit testing and just integration testing in professional development. But as of now, we don't have the requirement of that. It's will be too much burden to do, but at least we'll integrate the different parts of the project and make it presentable and do some basic testing that everything is working. And any bug fixes, if they come, we need at least a week for all the bug fixes. And then final week where you make the report, make the documentation, make the presentation, and give the final presentation to all the mentors and myself and the team here. So that is pretty much it. After that, we'll wrap up the program after an announcement of the leaderboard, what it was looking like at the end of the program, and further sessions later on. Which will tell you more about what are the other programs going on, because the conference will be coming up right after that, and some of you will get a chance to also present at the conference the project you developed. So that is the kind of roadmap. Some of you will be becoming campus ambassadors for your own campuses and running societies and projects over there. Will be helping you do it. Some of you might be running meetups in cities across India. We have 10 regional groups, so we'll discuss all that. That's going to happen. So each phase in this program is going to have specific deliverables at the end of every week, which the team, you guys will sit and make sure you have that deliverable done. So let's go forward and go ahead with the point of contacts we have for you. At the end of this breakdown session, you will have a very clear clarity of what each project is all about and what is the roadmap like. So the point of contacts, Rebecca, I will like to introduce all the point of contacts that we have for the project. So after that, we can take forward my session.
Hey everyone, I hope you all are having a great morning. So yes, we have new program managers who will be, working along with me throughout this program to help you take your first steps into blockchain development. So yeah, I would like all of the program managers, if you are here, to just present your screen, and I mean to just turn your videos on if possible. Otherwise, as soon as I call out your name, you can just say like hi or something. So we have Soumya Pandey with us. She's a student from IIT Kharagpur, and she will be handling the projects Tic Tac Toe, To Do List, the Web2 app clones, Bit Blogger, and Tornado Cash. So these are all the Escape projects that we have, which is one of our partner organizations. So Soumya, are you here with us?
Yes, thank you so much, Rebecca. Thank you, Rohan. I'm excited to be here, and all the best to all of you.
Yes, so this was Soumya. Next, we have Abhinandan with us. Abhinandan is also a student. He is an undergrad, and he will be, program managing the projects Metalog, Manthan Dex, Bitcoin document format, ordinal widget, and event base. So yes, that's Abhinandan. And Abhinandan, are you here?
Yeah, hello Rebecca. Hello Ron. Best of luck all the guys who is doing the.
Next up, we have Rahul Ranjan. So Rahul is going to be program managing browser activity trace, dev board, tab manager wallet, ultra forms, and Zapier marketplace ESP integration. So he is also an undergrad, and he will be working with you guys throughout your blockchain development journey. So Rahul.
Hello everyone. Thank you, Rebecca. Thank you, Rohan. All the best for your contribution, guys.
And we have an MBA grad along with us. He'll also be program managing 5 projects. He is Ishan Pal. He will be handling the projects BDFS, Payout, MetaNet browser extension, micro credentials, Bitcoin payments plugin for WordPress. So these are his projects. I'm not sure if he's here. Ishan, are you here? Okay, no worries. So all these program managers, along with a few more, like as you can see, there are we have over 40 projects associated with our program. So there'll be more program managers coming on board. And don't worry, I will introduce them to you guys. And throughout, starting from today onwards, they'll be interacting with you over Discord. They will be establishing a communication with you over WhatsApp. So yeah, stay tuned. You are going to be having a good buddy with you throughout this journey who will be constantly communicating with you about all the upcoming sessions, about all the courses that we are going to be planning for you guys to, take your skills to the next level. So that's all about the point of contacts slash the program managers who will be helping us in running TimeChain Summer of Code this year.
All right. Thank you, Rebecca. Yes. So, guys, we have about 20 people in each project. You are a team and you have to work together. The point of contacts will be making a WhatsApp group for each of your projects, and you will be having daily sessions. It's called daily stand-ups in software development. Daily stand-up session in which you will have the brainstorm session with your team, and then throughout the day you will work on the respective tasks that you assign or issues that you assign to each other, and then work on it, and then meet at the end of the day as well to catch up on what was the work done throughout the day. That's the format we're going to have. The point of contacts are also going to arrange the meetings with the mentors. We'll just tell you what the meetings are going to be. They are going to be mentor meetings every week, one mentor meeting with your project team, where you can ask all the questions to the mentor wherever you're stuck. Have the blockchain architecture guidance also with the mentor. Mentor is always available on chat, of course, but of course we need at least one meeting in a week with online call chat with the mentor so that you can have much more progress. Daily stand-ups, of course, as I just told you, we're going to have that organized by the point of contact every day. You will have your attendance also tracked in those daily stand-ups. Review meetings is with me and the project manager called Revati, who is going to be managing the Jira and guiding you all on how to be using the project management software called Jira. In the review meetings with me also, a lot of your doubts can be cleared on the direction of the project and making sure you are on track and have some of the problems also solved. So one review meeting with me is also there for every project. Project manager meeting, so this is separate from my meeting because that's the end of the week meeting where you are presenting what you have done in the entire week or reporting what you have done, and making sure you're ready for the presentation session. So expert edge sessions is the session like I'm having today just after this one combined, in which I'm going to have you go through a presentation of deep dive into learning about blockchain application development. We have the next one planned with Zawe and next one with Ty Everett, both from Silicon Valley, working on as founders of different companies, taking that expert ed sessions and teaching you different things of how to develop Bitcoin apps or blockchain apps in general. Presentation sessions is your sessions in which you are presenting whatever you have done or reporting and the final session as well. So that's the brief breakdown of how the meetings and stand-ups are going to be like every week. Project groups, right? So the first thing now is going to be a kickoff meeting in the next few days. Most of the projects will have within 2 days the kickoff meeting of each project with me. Your task is to make the product requirement document. I'll tell you what all it covers exactly after this, that document. Then that is a task for the entire week. You have to research and design your entire project and roadmap. Points-based system. So the points are allocated for this phase of the project as well, just like we had for phase 1. So the point system is like a leaderboard again. Your entire team gets the same amount of points. So you have to work as a team to make sure you get this product requirement document done. And the top team gets 60 points. And till the last team, based on the level of document that has been done, we allocate the points. It's the leaderboard as well. So 40 points, no, around 30 points go to the last team. So it's a step-by-step function, like 60 points to the top team, 59 to the next team, 58 to the third team, 57, like that. It just goes on till the 40 projects, and around 20 to 30 will still going to announce that number still. Based on the amount of work that comes in, we're going to allocate the points to you for this phase of the project. Then we're going to have leader appointment based on the work that you guys all did. One project leader automatically you guys will select and appoint as the leader for the project, who will be making sure you're on track and presenting to us among you guys itself. And you guys also have an opportunity. We'll launch a post as well for each. Whoever is interested in more of a coordination work can and wants to is going to be selected later on for the campus ambassador role. If you want to go on that track, you can also be wanting to work with us on the project coordinator position for your own team. So that's where we are headed. Okay, I think that is going to pretty much clear the structure of everything. But the product requirement document, let me just cover that briefly before we head into deeper topics. So here we have the structure of the document. Let me just show you how the product requirement document looks. So the first thing is you will get a clear and concise description of the problem defined in the problem statement. That's the first section of the document. I will be telling you the problem statement very clearly, but you have to understand it and detail it from your end with the problem background in that document format. So this is basically the white paper drafting phase of your project. You're drafting the white paper of what the problem nuances are, what are the complexities and subtleties of the problem, the different aspects of the problem. Cover it, research it, and just write it. And based on that, then the next part is to come up with the solutions, the potential solutions. There could be multiple ways of solving that problem. You can write the pros and cons of each if there are multiple and justify why you're choosing that solution. And then the impact of that solution to the users and the wider ecosystem, and have a feasibility whether that solution that you're coming up with is feasible to be developed, because most, if in the advanced project at least, it's going to be so difficult for you to achieve it in 3 months. So you might have to turn down the scope of what you can achieve really in 3 months. If there's going to be technical challenges, what are they going to be? How are you going to overcome them? Some bets or some risks that you're taking in time or cost. We are always there. There are resources, mentors, and everyone available for you. Designers also, I will just be announcing that as well for your project, to give a good landing page as well as a good logo, as well as a good design for each of your projects. So you come up with a recommended solution on a detailed basis, and then you break it down into Jira board for that solution in the next week, where you break down every single module and issues of the project. So that is how we're going to progress. While we are doing this, we will be having you go through more courses so that you're ready on the back-end development part as well as the front-end development part. Our tool tech stacks, we recommend our Nest.js on the backend. That's why we have been telling you to learn JavaScript or TypeScript ideally. And on the front end, it's Svelte as a framework for development. React can also be used for some team projects if you are already familiar with React, but our recommendation is a module called Svelte. You can also learn it very easily. It's very easy to learn, that everyone can use. So that is what we have been sharing on the front end channel as well, for the resources for you to be developing the different projects. So while we are doing this project design, requirement document, and design phase of the projects, you meanwhile keep learning on the side. There's these different courses that we have shared with you, which are deeper into development, particularly for beginners who are beginning with development, with front-end development, let's say. Go on. Also do mention the references of the research, wherever links you're coming up with, because you will be browsing through multiple different solutions which already exist and referencing them. So make sure you have that also in your document mentioned. It's the white paper essentially. Then, okay, that's pretty much it. That is what you have to make with your group, sit and make with your group in this entire week. Okay, guys, in the kickoff meeting, I'll give you the problem statement, and good luck to you guys for that. Let's begin with deep dive into blockchain application development. So Bitcoin was launched as a peer-to-peer digital cash system. The white paper name itself is this, peer-to-peer digital cash system. Now, every single word here has a meaning: peer-to-peer, digital, and cash. As we go on in this program, you'll get to know how beautiful Bitcoin and the blockchain really is. Bitcoin was made as bit plus coin. Bit means data. Bit is the unit of data, right? kilobytes, megabytes per second, gigabytes. It's all data, bits. It's all about bits of data. Bitcoin, the name itself, was made as the fusion of data and money. If your data packet, which is sent from your computers when you interact on the internet, is following the Bitcoin protocol, it is not just sending data, it's also sending data packet as a unit of cash, peer-to-peer, directly from computer to computer. That is what it was meant to be for a data economy. Have you heard the term data is the new oil? It's very popular in machine learning circles as well. Data is the new oil, which is used by the corporations. Most of the corporations today are built on edge and expertise over the huge amount of data they are collecting, like Facebook, Google, etc. All of them are built on data as their expertise. Bitcoin is really to power this data economy and decentralize the power of data to everyone, where you own your own data and are able to monetize your own data and earn from your own data instead of some other company earning as a middleman for your data. This was not exactly everything what Bitcoin is about, because this is a major thing what Bitcoin is about. A micropayment economy. As we go into the global data economy in the future, where Internet of Things devices are also streaming data, and it's becoming an asset that you need to control your own assets and have power over it, and also for security reasons. It becomes the underlying infrastructure for the new economy that is forming on the internet, called the micropayments economy. Now, what is the blockchain? The blockchain is the ledger of Bitcoin transactions. It's very simple. Every 10 minutes, you have different transactions that happen throughout the world. They are grouped in a block and added to the chain of blocks that make the history of the entire transaction history since Bitcoin was born in 2009, right? I hope most of you have already gone through the course, so you would have some kind of an idea of what this is about. But the reason I'm bringing this up is globally shared ledger is different from distributed ledger technology, which is the popular term. You need to understand what this is about. When you have multiple ledgers, you can't achieve globally shared ledger benefits, because that is what Bitcoin was supposed to do, is have a shared ledger for everything in the whole world. It's shared. That's why it's the ledger for everything. It's a globally shared ledger. You can have sub-ledgers for different nations, sub-ledgers for different projects, sub-ledger for different companies and enterprises, or different supply chains. But it's all sub-ledgers focused on different sectors or different products or different supply chains and companies, or governments even, or regions. But in the end, the benefits of the blockchain ledger come when it's a globally shared ledger. Then the different parts of the companies, different enterprises, different products can all interact on the shared ledger, which is a common basis. It's called the time chain as we go forward. So what is it really doing? It's a disruption in money itself. It introduced a peer-to-peer cash system without intermediaries, and that reduced the cost of payments to such a level where we can have micropayments on the internet. I'll tell you more about micropayments. Micropayments are payments like 1 rupee. Actually, any payment less than 10 rupee is called a micropayment. It's a micropayment to do, let's say, load a website, do a Google search, do a YouTube streaming video where you have payments coming in. You can have payments of 0.001 paisa also for some kind of data, because data is very cheap, right? Very small amount of data. If you're going to price that, that is becoming a micropayments. That's the data economy we are talking about. And you can program it. That's where smart contracts come in. You can program conditions on data that when you get the answer to certain conditions or certain data that fits certain requirements, only then the Bitcoin is unlocked and you can spend it. That's where the programmable micropayments come in. You can even schedule payments and have agents, wallets having your agents representing you, doing automated transactions. That is the kind of world we are going towards. A wallet agent representing you and doing transactions on your behalf. And you're going to interact with the entire internet through this structure of the wallet itself becoming the sign-in into different applications. Right now, your identity is your email, right? You sign in with your Gmail or your email into different applications, sign up. Now your wallet is representing you. Just like your physical wallet is the closest thing you hold in your pockets and travel across the whole world. In the digital world also, we have the digital wallet now, which is going to hold your money, your identity cards, your data. It's going to represent you, and ID cards and coupons, tickets, just like what your wallet holds. It's going to hold all that. And then you can sign into different websites with those wallets, and those websites have their own wallets, and you interact with those wallets back and forth, and do payments and data exchange with those websites. So that's where we're going with the new internet. And I'll tell you why we are going there. So what we also have is tokenization of other assets on the common shared ledger, which we call the blockchain, which is assets different from Bitcoin itself. So Bitcoin itself is an asset represented on the ledger and exchanged on the ledger. But there are other assets you can tokenize. You can tokenize this laptop, you can tokenize your mobile, you can tokenize and represent any asset on the ledger itself. And then you can program the ownership of it and write contracts on basis of that ownership. Mainly, instead of physical asset, it's more about digital assets. I'll go further into that. So that's how you're going to tokenize the whole world on the ledger. And you're going to have a common shared ledger in which a huge amount of data will be unlocked. Imagine the amount of data that is still left and not connected, disconnected silos of data. That's what we're really solving. HTTP error code 402. So HTTP protocol is what is running on the browser. You see every website has HTTP written, and then you have the website name. That is the protocol that is getting followed. So it has this error code 402, which was never completed. HTTP wasn't completed. It couldn't have a common payment protocol made for micropayments that was supposed to be achieved at that time. We couldn't have it because the technology wasn't there. So Bitcoin really completes HTTP, and it provides now payment along with data exchange. So that is where we have gone to now with Bitcoin. So Bitcoin, beyond just electronic cash system and a distributed ledger, which is blockchain, it also is a programming language, have smart contracts on it. But you can also have a data network that I just told you about, like the internet, is going to power the data economy. And it's a network protocol at the level of transport layer protocol, which is called TCP on the internet. It is at that level. And with that, it provides a very foundational data economy infrastructure for the internet. So you can see that there are different layers of the internet, actually. If you have worked in computer science or network theory, you will get to learn there are OSI layers of the internet. So in those layers, Bitcoin basically falls into the transport layer. It's transporting not just data now, but transporting money. That's why it's the transport layer for the internet. Protocol wars, there are many different protocols. It's not just about Bitcoin. There is Ethereum, there's multiple different protocols that have come up after Bitcoin, following the same vision of Bitcoin to achieve different things. But Bitcoin was hit with different roadblocks, and I'll tell you more about what happened in the history. Those created multiple different blockchains to solve the problem that Bitcoin had. So this is how different blockchains like Ethereum, focusing on smart contract, Polygons focusing on scaling, EOS, and many other blockchains have come up. They're all different blockchains with their own tokens, just like Bitcoin. There are multiple protocols, but as happened in the internet phase also, when internet began, there was really no standard for IP, internet protocol. There were multiple protocols by different companies, every single private company coming up with their own protocol. X25 also existed. There were many different models, and they were all competing to become a global standard for the internet. Because without a global standard, you can't have the entire internet running in a common shared fashion, just like we have today. But then again, silos get formed, then you're not able to achieve the information communication. In the end, there's a common shared communication protocol across all the protocols, which is also coming up, like inter-blockchain communication and stuff, inter-blockchain ledgers, which communicate different ledgers. But in the end, it's coming to a globally shared ledger, as Bitcoin has envisioned. And it has to be, just because it's the most public ecosystem. It's the network of networks. That's what internet is about. And that's the same thing with blockchain. It's the network of networks. You can still have private or permissioned ledgers or subledgers, just like you have permissioned networks in your campuses. Also, you might have noticed you have permissioned internet facility in which only some websites are blocked and some you only access through a proxy to the entire internet. But that's a local network. So just like the local network is part of a bigger network, which is the global public network, you have a common public network. Inside that, you have shared subledgers or permission-led subledgers. That's how it's going towards in the future. Micropayments on the internet is the original purpose of Bitcoin. It is written in the first few paragraphs itself that the minimum practical transaction size is too high with the PayPal and other payment methods of today. Credit cards also cost multiple percentages. And Bitcoin came for possibility for small casual transactions, basically micropayments, small payments for data on the internet, so that you can have micro interactions powered by data and unleash a new economy. That is the purpose of Bitcoin, which wasn't achieved. And we are the team as Big Blockers and Bitcoin SV, Bitcoin Satoshi Vision, we are focused on this, that we achieve the original purpose of Bitcoin, as you will get to know further on. Metanet or Web3. Web3 is the popular term for it, but in Bitcoin SV space, we call it the Metanet. Metanet is the new world of micropayments, where you can earn by writing articles, you can earn by writing Wikipedia posts, you can earn, instead of you have to contribute for free, you can earn from a lot of things. It's earning and spending. You can earn from games, you can earn from your social media, likes and interactions. You have an economy powering it. That's how you move away to owning your own data and earning from your own data. And your own contributions to the internet. So it's a give and take type of earning and spending economy that we're going towards. Why is this important? Because right now what has happened in the Web 2 space, so as you guys must have heard, but I'll reiterate, what is really Web 3 about? Why is it called Web 3? So in Web 1, essentially you have one server which is posting the data and everyone is consuming it. No one can contribute to that, what is getting hosted. In Web 2, people can write also and contribute to what is getting hosted. You can make comments, you can make your own posts, you can contribute to the database. But still the database is owned by a single corporation who is then monetizing all the data, and it is having an advertisement model of distributing content. So if you are posting, it is providing a distribution of your content to everyone else. Facebook is distributing your post to your friends and other people. It's connecting you. YouTube is distributing your video that you post to everyone else, and it is earning money through that, because its advertisement is how they earn money. So this is the model that has happened right now. So people don't own their own content, and they're not able to choose the different hosts of the content, and they're not able to choose their own monetization for their own content, because they don't have ownership over what the content is and what the price should be for that content for people to consume, because micropayments does not exist also. So in the new model of the internet, the Web3 part is where instead of you writing on a common database of a company owned by that company and everyone being dependent on that company itself, having a monopoly on the distribution network, content distribution network, and then whoever has a monopoly on the distribution network is either distributing the content because you pay them, which is advertisement, giving access to distribution, or censoring you because they don't like you or your content, which is not politically aligned with them, with that company. So this is also disturbing the societal fabric of democracy and other things, and our own interests of everyone to be controlling their own distribution of what they want to distribute, how they want to distribute. So from this model, which came with the Silicon Valley, we are moving towards a more decentralized version where you own your own content through your wallet because you post, and interact with others through the ledger as the intermediary. And the ledger is a free market for distributing transactions. That's what the blockchain is about. Every miner is accumulating all the transactions throughout the 10 minutes and then broadcasting them in a group called a block to every other miner as a block, and the block is added by every other miner and the blockchain continues. So essentially what is happening is miners are distributive agents who distribute transactions throughout the world. So they are distributing transactions and they are in a very tight competition of every 10 minutes they're having to distribute transactions. And if they're not performing well, they get outcompeted by other miners who are better than them. So this, instead of the monopoly on a common private database owned by one entity, pricing things for everyone and deciding and giving the service whatever they want and selling however they want and censoring however they want, you have a free market for distributing transactions, which is distributing content essentially. And that's how we can monetize the content in a new way, which is the new internet economy called the Metanet or Web3. There are diverse use cases of the blockchain in every single sector, because imagine it's a globally shared ledger. So everything can be represented, everything can be tokenized, and that's how you represent it on the ledger. And then you can have contracts interacting between different tokens, and you can have benefits of the blockchain in that sector, whatever it is. Time chain, what the blockchain really is that so? Why is my company called TimeChain Labs? Why are we called TimeChain Summer of Code? Why is this program called this? This is because blockchain is not exactly the right term that Satoshi Nakamoto, the creator of Bitcoin, used. He used time chain. And if you understand this term well, you will understand blockchain than 99.9% of the professional industry in the space as well. Time chain achieves a timestamp server. This is written in the Bitcoin white paper as well. You are hashing blocks. I'll tell you more about hashing, what it is all about, but it's having data integrity that once you timestamp some transaction or some data that this thing happened at this moment in time, this event or this signature of yours happened at this moment in time, you can't forge it in the future. So it can't be changed. That's the etched in time property of the time chain that time chain provides. And that's why there's the model of Bitcoin that buries blocks one after the other, such that the more the block is buried, the more economically difficult it is to change the block and change what happened in time in the past. So something that has gone 2 hours ago, it has been mined and buried by the miners with a lot of proof of work so that it cannot be changed. The past cannot be changed at all. And it provides a strong time chain, which is linking every single event that happens across the whole globe in this time chain. So this provides the fundamental infrastructure for the new internet. That is the time chain. Now, this is the comments of the code of Satoshi itself. If you go to Bitcoin 0.1 version, the first launch version, he mentions the time chain is a tree-shaped structure starting with the genesis block at the root, and each block potentially having multiple candidates, and he just goes on explaining what the time chain is about. And he always mentions the word time chain. He never actually calls it the blockchain. It's the other people who popularized it later on as the word blockchain. But if you understand really what the time chain is about, you will understand how to design smart contracts well. What should be on chain, what should be part of the time chain, what should be timestamped, and what should not be timestamped. What is private, what is off chain. And that is the way you properly program smart contracts. That's why it's going to be very, very important for you to understand what a time chain is. What has happened now with the blockchain bubble is that there are multiple different blockchains and multiple different cryptocurrencies, all vying for achieving what Bitcoin did with the hype, with the price going up. But this Bitcoin bubble of around $20,000 per Bitcoin, or even going to $60,000 in the last few years, was a big bubble, just like the dot-com bubble. You know what the dot-com bubble is about. It is the dot-com bubble that happened when the dot-coms came, the domain names came first on the internet. Everyone was buying the .com just because it's a .com, and everyone thought it's going to be the next big thing. It was the next big thing, but at the same time, there were valuations of dogfood.com which didn't have any business model or didn't have any proper team behind it. But just because some team just came up with the brand name of dogfood.com, which can sell dog food, and it was going till millions of dollars of each company in that valuation. And it was a hyped and speculative investment cycle, which just rose up, not grounded in utility and actual business fundamentals. This is what also has been happening with the great crypto bubble. This is a term coined by me, but this is going to become popular. As this bubble pops, just like we know the dot-com bubble was there in 2000s, we're going to have the 2020s great crypto bubble, which is going to already popping, and it might pop further on. Because this is a healthy requirement that the ecosystem comes through the understanding of what the time chain is really about, what the Bitcoin was really about, what the economy is really about, what the shared ledger benefits are. It has to be grounded on utility, because where is the price of Bitcoin coming from? Really, if you understand that, it's not just about scarcity that people are hyping up that, okay, because that thing is scarce, it's going to go up in price. There should be a need for it. There should be a use case for you to hold Bitcoin. There should be something that you can use it for, or any NFT also. You can use that token for something, only then it has some value in the first place. And then when it is scarce, that's the secondary thing that's applied for it to get a price. But fundamentally, Bitcoin is used to pay transaction fees to make a transaction on the common shared ledger. So Bitcoin has a fundamental grounding. So if the shared ledger is useless, If you don't want to use it, if there is no use case for you to make transactions on the shared ledger, then Bitcoin is useless and it won't have any price. If you have apps that use the ledger and there is Bitcoin needed to pay transaction fees to use the ledger, then you have an economy and you have a demand for Bitcoin, and then you have a utility of the ledger, then you have a use for Bitcoin, then it has a fundamental base ground price of it that gives it utility. This is what our community is all about. We have the Enterprise Utility Blockchain Summit as well, and you will get to know as you get deeper into it. We focus on utility of the ledger, and we measure every single application not by the price of the token, but rather by the number of transactions created on the ledger, on the shared ledger. How much use of the ledger was created through your application. There was a big scalability debate that happened. When Bitcoin was launched, it was supposed to be a micropayment ecosystem with zero transaction fees, almost zero, 0.001 is zero transaction fees. To enable a global economy, for that you needed a huge number of transactions. But Bitcoin and its roadmap was suffocated. It was not allowed to scale by the teams that hijacked Bitcoin protocol as BTC right now. It was not allowed to be sticking to the original version and achieve scale by increasing the block size and having a free market of block production and consumption, which was the vision of Bitcoin. So this created multiple different blockchains. Also, what was not allowed in Bitcoin was smart contracting. Ethereum came up to do smart contracting, but the creator of Ethereum, called Vitalik, wanted to do smart contracts on Bitcoin itself, and he was denied from the group of developers that he can do non-standard transactions on Bitcoin. And that's how Bitcoin was suffocated. And that's where Bitcoin Satoshi Vision was born, to restrict and achieve, to restrict the changes from any changes to the protocol and achieve the scaling of the block size and preserve the protocol to how Satoshi designed it without any changes to it. So BTC is the popular version of Bitcoin, but it is more of a distraction. It is not the original version, and there have been multiple changes to the protocol introduced in Bitcoin as BTC. There is Lightning Network and segregated witness. Segregated witness is what introduced it and created a huge debate, because it was introduced to increase the transaction capacity, but it didn't do it the way Bitcoin had the vision to do it, by scaling on-chain on the layer 1 blockchain itself. It rather did it with Lightning networks, off-chain, second layer networks, and other things. But you know, the secret and the beauty is Bitcoin could always scale. It could scale more than Visa. It could scale to power the entire global internet, just like email scales. You don't have a scaling limit on email. Email is peer-to-peer as well. You have entire amount of emails sent throughout the world, millions and billions of emails. Imagine if email protocol was suffocated. That's how Bitcoin was suffocated. But with Bitcoin Satoshi Vision, we have restored the ability to do smart contracts on Bitcoin, and you can do more powerful contracts in a better way than any other blockchain. This is the genius of Satoshi that we recognize, as well as it can scale beyond the capacities that we require for even national transactions. Because for a global internet transactions, you need millions. Not even Visa scale is nothing compared to that. It only hits around 50K transactions per second. So we need thousands and millions of transactions per second. So that's where that is about. Now let's come to what Satoshi Nakamoto really said. This is his quotation himself. The existing Visa credit card network processes about 15 million per day. BSV actually, by the way, already has hit 20 million on the record hits. But with Bitcoin, he said that Bitcoin can already scale much larger than that with existing hardware for a fraction of the cost. So the big scalability debate that created multiple blockchains was not even needed. If you really scale the Bitcoin blockchain itself, you can achieve both smart contracts as well as scalability and low transaction fees. That's the design and genius of Bitcoin. So in Bitcoin's history, what happened is there was a scaling war. If you see this structure of the diagram, there was a war which created Bitcoin Cash first, which was the Independence Day, we used to call it in the community. The hash war resulted in two splits. Bitcoin finally got released from the clutches of the developers who had hijacked the project after Satoshi left in 2011. And then it was allowed to increase the block size. Imagine the block size was limited to only 1 MB. It's still to this date, it's only limited to 1 MB in size by the developers in BTC. Now, Bitcoin Cash increased it to around 8 MB and then later on till around 32 MB, which is till date. But then it stopped there. And Bitcoin SV continued to be fighting for the Satoshi's vision to be realized and achieved with the Genesis upgrade, everything back to any changes brought on by the developers beyond it were restored back to the Genesis version of Bitcoin, and every restriction that were put on it were also removed. The block size restrictions were removed, and the smart contract restrictions were removed, and that's what created the genesis of BSV. And now we're having the Terra node with terabyte size blocks capability getting developed and getting used in Bitcoin SV ecosystem. So this is the focus on scaling Bitcoin and having developers develop applications using Bitcoin itself. So this is the history and background of Bitcoin Satoshi Vision. As I was telling you, email protocol, if it was restricted to only 7 emails per second, imagine for the whole world, imagine it wouldn't be popular at all, right? Because 7 emails per second, it wouldn't be usable also. But today it does 2.4 billion emails per second globally. So this is the scale you really need, and it can be achieved because Bitcoin is also peer-to-peer protocol, just like email is peer-to-peer, and you have your own email servers, and then you're able to send emails to everyone, and it just works. Bitcoin is scalable at that scale, and we need to achieve it. Imagine you having your whole world sending only 1 MB worth of emails in 10 minutes, in entire 10 minutes. That is the restriction that happened on Bitcoin. But now we have achieved a lot of scale, and we can achieve already millions of transactions on the ledger per second. World record blocks. For that, we need not 1 MB size blocks. We need gigabyte size blocks, and soon we'll need terabyte size blocks every 10 minutes. That's the level at which the competition needs to happen, with miners becoming data centers, because it's about data economy. And you have around 2,000 data centers across the world, and you will have around 2,000 miners around the world. They will be basically data centers powering the data economy. That is where the future is going towards. Imagine a photo on your phone is also 6 MB or 5 MB in size, a good quality photo. Imagine the whole world's transactions in 10 minutes restricting to only 1 MB in size, even 1/5 of your photo on your phone. This is how badly it was restricted, which is all a very, very deep falsity. You can achieve gigabytes and terabyte size of blocks per 10 minutes. Bitcoin is a natural payment fit for IPv6. You know what IPv4 is about? It's at the fundamental layer of the internet in which you have IP addresses. IP addresses are like 10.06.106.2, something like that, is your IP address. Every device has an IP address. Bitcoin was created for the next version of IP, which is called IPv6. It's by the European Technical Standards Committee itself. They have also shared in a report, and you can also check out how Bitcoin SV, the original version of how the Bitcoin protocol was supposed to works is a natural fit for IPv6, because that's how Satoshi designed it. And with that, we can really achieve the peer-to-peer internet of micropayments at the layer of the protocol stack. It is very clear that they mentioned that Bitcoin payments fit naturally with the IPv6 addresses, and they just link in so clearly that it's just a genius method that Satoshi already envisioned what IPv6 was all about. So have you heard this term TCP/IP, TCP/IP, TCP/IP? Instead of that, we are going towards a world where we are going towards BSV IPv6, BSV IP. So at the transport layer protocol, the innovation is really happening. This could be some later on your thesis projects, probably when you take on your BTech thesis or your PhDs. If you are really interested to deep dive into it, you will be working at this level and writing your papers on this. That's also something we can support. Triple entry accounting, as you must have gone through the course already in the Bitcoin basics, you must have been told what triple entry accounting is all about. Does anyone want to answer what triple entry accounting is about? If you must have gone through the course, you would have also come across this term, or if you know, would like to share, please raise your hands. Yes, please, Rebecca, could you just point? Whoever, I cannot see the screen much, is raising their hands, they can have a chance.
Yeah, Ikram is raising his hand.
Yes, please.
Yeah, hi everyone. So, from the course, as far as I could pick up, triple entry accounting means that whenever a transaction is done on the blockchain, a receipt is generated for the one who is paying, the one who is receiving the payment, and the transaction is published on the blockchain for others to verify it. So it makes the transaction transparent.
Exactly. Yes, that's very correct. Essentially, triple entry is the third entry, which is the receipt that you mentioned, right? So right now, the whole world is based on double entry account bookkeeping. So you have your book of accounts in your bank, and I have my book of accounts. You have your credit and debit, two separate ledgers, credit and debit. I have my credit and debit. And then when you pay me, it is added to my credit and your debit. Now these two are not linked and connected. Now auditors come and accountants come and they keep on checking whatever you are claiming is what I'm claiming, whether I received what you really sent, and then matching what the payment was for, all of this. So what Bitcoin does is follows a triple entry accounting ledger model. That is the blockchain really. It's the third entry, the common entry shared between these two books of accounts, linking both of them as inputs and outputs. And those are linked into a single transaction and time-stamped onto the time chain, ensuring that it provides a new self-auditing accounting ledger. That's the innovation of the blockchain. Because then auditing costs go less because you don't have to do much. You can see that the transaction has not been forged. It's etched in time. And these were the inputs and outputs. These were the credits and debits. It's linking both the accounts. So it's time-stamped ultimate record keeping system, which cannot be spoofed, cannot be changed. And it's highly trustworthy. That's why it creates the trust. And it's all about mostly accounting. That's where the innovation also happened in blockchain. Now, but this innovation, what interestingly happened in the space is that you have now multiple different ledgers called distributed ledger technology, multiple different ledgers instead of a shared ledger. So you lose the benefits of linking the different transactions into a single shared ledger and having an accountability of that. When you have different ledgers and again data silos forming for those ledgers, and you can't link the transactions in both the ledgers, what is getting claimed, and you're losing the ability that was achieved with the globally shared ledger, which is linking the different transactions and having authority of the time chain, linking everything. So decentralization has become a term you will notice in the industry. Decentralization was not the primary aim of what blockchain was all about, or Web3 was all about. It was achieved through decentralization. But the game of the blockchain is to achieve data network where there is a free market of block production and consumption. The free market is the main thing. The monopoly of one entity with a private database is removed, and instead you have competing miners. That is better than having decentralization as the highest value. Because when decentralization becomes the core, it's not about competition and best free market, but rather it becomes more about making sure you have a Raspberry Pi be able to run a Bitcoin miner, which is not possible, because I told you it's going to be a level at which you're going to have terabyte size blocks and data centers competing with each other. That's the level of miners. You can't have Raspberry Pis competing with each other. So this is why we have the core as a free market instead of decentralization as the primary goal. It was a free market naturally achieves competition and naturally achieves decentralization because multiple entities can compete. But and now distributed ledger is a little bit different. If you can have distributed power, that is good because you own your own data and you are able to do things peer to peer with each other. That is nothing to do with miners. But this is something which is very technical. As you deep dive into the space, you will get to know what this debate is all about. So right now, why the term distributed ledger technology is also a bit correct, but also a bit wrong, because you are not able to design the correct structures if you follow this structure. You have to keep in mind the shared ledger technology keyword and think in terms of a shared ledger instead of multiple distributed ledgers. Because already Facebook has a distributed database, but they're all private database and they're distributed across the world. They have thousands of nodes replicated so that the system doesn't die. Every single company who's a professional website has distributed databases. It's nothing new. So what is really new is a shared ledger in connecting all the different databases. That is what is new, and that is what the innovation is. So that is what it's about. Now what you're doing is, as I was mentioning you, what is tokenization? As we go deeper into the lecture, we'll also learn how the tokens are represented on the ledger. But essentially, Bitcoin is represented on the ledger as a token. Along with that, you can tokenize physical objects as well as digital objects. You can tokenize both of them and represent them on the ledger, and then you can write contracts for them to transfer their ownership. So that is what it is about. You can tokenize anything in the whole world onto the shared global ledger. What is the use case of it? The very fundamental use case that comes is the content economy right now, which exists on the internet, because the internet is all about content, right? Creators are creating posts, tweets, videos, photos on Instagram. It's all about content. You are creating content as a creator yourself. This is the Web 2 world. Now in the Web 3 world, digital rights management is a term also you can research. You have content rights for your own content. You can give access to who can view your content, right? You can give access even to who can write and use your content or your creation of a logo, who can use on their websites, who can use with how many views, how they can use. So that all is getting tokenized, and you are able to earn from the content you create. So it's a fundamental level in which digital rights management happens through tokens, representing the view rights and read rights and write rights of every right represented on the ledger. And then you can have ownership over your own content, and you're able to decide the prices for it. You're able to decide who you share it to, and you own your own content. That is what it is about. Then also real world objects getting tokenized have tracing and tracking capabilities, where different supply chains are becoming more optimized and able to figure out the problems wherever they are by interacting on the common shared time chain across supply chains. And then you can innovate on the content economy with new financial models that do not exist. That's where startups like you guys can also come up with your own ideas of how to monetize. And these projects itself, which you're working on, could even work to become the new phases of new startups, which are going to disrupt the existing business models of the Web 2 space. Now I'm going to tell you more about what the blockchain looks like, really, to give you more of a feel and where you can read more about it. So the most popular explorer, just like you have Internet Explorer for exploring and the browsers for exploring the websites, right? The internet. You have an explorer for exploring the blockchain as well. That's called the block explorer. And the most popular explorer is what's on chain, or Bitcoin Satoshi Vision. So what's on chain is going to give you exactly what's on chain. It's going to give you all the blocks and all the transactions that happen. So you see here this is the latest. This is the latest block, 5.4 MB in size, by a miner called Tal. Before that, you had the block number 792837. Now this is the blockchain going past in history, all blocks linked. And it goes back to history and Genesis as well, when Satoshi, the creator, started the Genesis block, which was block number 1. Right now, we are at block number 792,838. Every 10 minutes, approximately, you are having the blockchain getting constructed. And each block has all the transactions that happened in those 10 minutes across the whole world. And it is these miners who are adding to the chain of blocks. Now, some blocks are 17 MB in size, depending on the demand that was there at that point of time, that those blocks had those amount of transactions. You can see there are 5 MB transaction, 17 MB transaction, 19 MB transaction. The biggest transaction that has happened ever is 4 GB in size. There was a huge demand to the network at that time. Also, some testing phase was going on, and the network could achieve 4 GB in size. But we are constantly pushing with more transactions. As I told you, that's the main aim. If we can achieve consistently applications that are developed by you guys that are hitting thousands of transactions, I say this, that you have to achieve 1,000 transactions per day from your application, whatever you developed, at least. That's a good metric to follow from different users. So this is what we think. Now, this is every block, right? This is block number 792,000. If you go back, you can keep browsing through every block. Now, if you go inside, click into a block on what's on chain, you will see, let's say, let me go into a big block, 6.3 by Gorilla Pool. This has a block height. Why do we call it a block height? Is because blocks as you saw in the chain of blocks, right? There was the top block, then there is another block getting built on top of it, then another block built on top of it. So you are burying blocks. That's why it's a vertical. You can think of it as a vertical structure because it's like a time chain, right? So you are burying blocks in time with more and blocks added. Now there's a lot of work getting done. You will see there's this previous block and next block. Now what do I mean by work? Miners are solving a hash puzzle, which is difficult to solve, which is a lot of work. That buries the block in time, and when there is a new block, it buries it in height. So there is a new block height every time. Now, this is what really secures the time chain, because then the amount of work cannot be replicated. Because if you want to replicate and create your own spoof of what the history was about, you can easily do that in the digital space now. But once you have that proof of work method, burying blocks in time where there's actual work, actual energy, that's making sure that it's in the past, and to make changes to it, you have to do the same amount of energy expenditure and work and prove it. This is what secures that this is the latest time chain, and this is the single shared latest time chain of records of events that happened in time, replicated across the world. It's also going to solve the problem of libraries of information getting burned and humanity always having to lose information again and again. Imagine a shared time chain linking all the records in time, and once it's written there, it's written there. And records and history are replicated through the servers across the whole world with not one point of failure. So this is the new data repository of the whole world. Okay, so what's happening here is you're having transactions. As I told you, right? Every block is having a list of transactions added, whatever happened in those 10 minutes. So this has the list of transactions. It's very simple. Now there's transaction number 0 in that block, which has the new coins created and coming into circulation. I'll leave that for now. Let's look at some standard transaction. Let's say here. Now a standard transaction has inputs and outputs. Let me pick out. So these are different applications. Like when you also make an application and it has a transaction, it will have a tag. This is one website which is making that transaction. This is another OP written protocol it's following. There is multiple different transactions that can happen that way. Now what I want you to look into is a standard payment transaction. It's better if I, let's say, go into this and go into, let's say, run protocol. No, let's say go into a standard transaction. Yeah. What you have here is inputs and outputs. You have, this is the structure of what Bitcoin is. Just like your notes of cash have notes of cash you take in as inputs. Like you want to pay 150 rupees to someone, right? How do you do that? You combine 200 rupee notes as inputs, you spend it, you give 150 rupees to that person and 50 rupees back to yourself. So those are outputs. 150 rupee output number 1 is what you will make, and 50 rupee change back to yourself is output number 2. Inputs will be 100 rupee one input and 100 rupee second input. So those are the tokens. So which you can, now right now they are all about Bitcoin. I shouldn't have actually used the first transaction because this is the first transaction. So there are newly minted coins. So in every block, there is newly minted coins coming into circulation. Right now, it's 6.2 Bitcoins coming into circulation. But instead of the first transaction, if we had any other transaction, let's say look into the run protocol. Yeah, this is better. This is a smart contract called the run protocol ecosystem. Anyway, I'll get into it deeper. But there are 2 inputs and 3 outputs. What is really happening? Can you see this total number of inputs? As I was telling you the example of spending 200 rupees, you were combining 200 rupee notes, right? So all the inputs amount of coins are getting combined and you're having the total number of inputs. Now, obviously the amount of tokens you can spend is going to be less than the tokens you have unlocked, right? You're spending. So around 0.01 coins are getting constructed as outputs. Outputs are always going to be less than inputs, right? You can see this number is also less than the inputs. Now the difference is the transaction fees by miners. So miners earn this difference in the output versus input. You can give them 0 fees, but then your transaction won't be included probably. So that's the transaction fee that they earn. So that's the incentive for miners to be adding transaction fees. Transaction fee economy is really what is going to power the entire Bitcoin ecosystem. That's why we need more and more transactions, because that's the utility of the ledger. The more it is used, the cheaper it becomes as well, because that's the proof of this scaling, economy of scale model of the blockchain, which Bitcoin SV follows. The more transactions you have, the difference becomes cheaper and cheaper and cheaper, and miners can support even larger amount of transactions at lower fees. Now, this input is something you're linking from a previous output of a previous transaction. You can see via transaction ID. This is another transaction ID and 1 here in the bracket. So when I pay you 150 rupees, let's say, as an output, so I create an output basket for you holding the coins. And I create an output basket for me, let's say, with change 50 rupees. So 100 rupee basket for you, 50 rupee basket for me that I can spend. Now wallets are simply baskets. Like right now also, imagine your physical wallet. What does it do? It's a basket that holds multiple notes of cash and coins, right? So it's holding multiple outputs which you can spend whenever you want to make a transaction. So whenever you want to make a transaction, what your wallet does is it looks at the output baskets it has, the list of outputs it has, which it has the ability to unlock and spend. Then it spends it as input of a transaction, and it just spends it by unlocking it, because only it has the ability to unlock it and spend it, because only it can sign the transaction which it received. And then it spends it, and then it can pay to someone else and pay to itself or make a smart contract. What smart contracts is this is a standard payment. Right now it's a standard script, but this can also be customized to write custom scripts. As I will go deeper, there's a script section in What's on Chain as well, in which you can look at the input scripts and output scripts. This will be very technical right now, very quickly, but I won't go much into it, but briefly tell you what these are about. But first, let me get back to the slides. I have told you a lot about What's on Chain. This is literally you being able to see what every single transaction, every single byte is about, and actually understand it deeply, right? This is why I wanted to give you a glimpse, because whenever your application, whenever you makes a transaction on the ledger, you will come and see that you received a transaction ID for it, and then you're able to fetch the transaction from the ledger and view the transaction on the What's on Chain Explorer and see what you really achieved, what you really made from your app on the ledger. Now, there is a wiki for understanding what the blockchain is about, which I recommend highly. You can read it, which is wiki.bitcoinsv.io. It has all the structures of what Bitcoin is about, what the network is about, what the ledger is about, what are the different transactions, what are keys, everything about Bitcoin. What is the structure of the blockchain really? Let me also get deeper into this. Let's go back to the slide. We'll go deeper and come back to this. So this is the ledger. Bitcoin ledger, which is validating all the transactions. This is right from the white paper Satoshi designed. Every transaction has owner keys as well. I will be telling you more about it briefly soon in a much easier fashion than this design structure. It's not that good. But what I'll tell you from here is that you are signing every transaction. It's really about signing, right? When you're having keys, those become your identity, and you're signing that you are sending this transaction to someone else. And with cryptography, you're able to have keys and you're able to sign different messages. Any messages you can sign with cryptography. So this transaction, you're signing that, okay, you are spending this. And when you are spending it, you are basically proving that you own the keys. That's why only you can sign. Essentially, that is the information lock of Bitcoin that is protecting the coins. That only you can sign it. That's why only you can unlock the coins. Now about the time chain. The time chain and the blockchain, the block headers. Every block has a block header, which is very simple in structure. It has a previous hash and it has a Merkle root. I'll briefly tell you what the Merkle root is about. It is very simple. And what are hashes about? Any transaction in cryptography, there are three things you need to know. First is signature. You can sign any message with your keys, right? Second, and you can then verify whether the signature is valid. Second, in cryptography, is encryption. You can encrypt any data with your keys, and then someone can decrypt it. The third aspect is hashing. Hashing is not exactly just like the other two, it's not having any identity, but any blob of data you can hash and represent a fingerprint of it in a small format. Just like your fingerprint represents you, that okay, you were there, you don't need your entire body to be there, only a fingerprint represents you. Entire data can be hashed and represented with a hash, a unique hash representing that data as a fingerprint. So that time chain is recording all the events in time, so it has fingerprints, hashes. Every transaction is hashed. Then you have an ordered list of transactions at the bottom of the tree. That's basically the list of transactions that happen in those 10 minutes. Those are all hashed. Then each two transactions which are consecutive are hashed in a binary tree fashion. It just goes up and up and up and up. Two hashes are combined to create another hash. Then those hashes are combined to create another hash. And this tree keeps going up to get the Merkle root, which is the Merkle root hash representing in the fingerprint of the entire list of transactions that happened in those 10 minutes. So this Merkle root is what we are protecting, this hash. And then we are chaining it by combining it with the previous block hash. This entire thing is also hashed. This is the block hash. Then that is getting linked as a previous hash. Then you're attaching the list of the Merkle root, which is the fingerprint of all this. So the fingerprint of the entire blockchain till now is the previous hash. You're linking it with this Merkle root. And then the miners are solving for this nonce. Nonce is a number which miners are iterating to figure out which number satisfies a constraint. That is the proof of work puzzle that they're solving. They are brute forcing through all the numbers to figure out the combined hash of this previous hash, nonce, and Merkle root. Now this entire thing is hashed. That is the block hash, block header hash. That hash is going to have number of zeros in the beginning. That number of zeros is the difficulty level that the miner is trying to achieve by iterating. If the difficulty level is very high, there is a lot of demand and a lot of people are mining on the network, the difficulty level goes up and you have amount of zeros requirement as 20 zeros in the beginning. So they will have to iterate through a lot of numbers to figure out one hash which gives them the combined hash as number of zeros 20 in the beginning. Now it could be that the supply is very low of the miners and hash power is low on the network. Then they automatically, to make sure that every 10 minutes the blocks are getting created, the difficulty goes low and you have only, like, let's say difficulty criteria of 2 zeros in the beginning, then the block is accepted. That's the criteria. So it's a moving average function which is targeting 10 minutes for difficulty level of the number of zeros in the block hash entirely. This is actually deeply the core of the time chain, the competition of miners that's happening in this hash chain. Now, what this hash chain is really doing, which is becoming a time chain through this proof of work of method, is that it's fingerprinting everything in time, right? These are all fingerprints of transaction. This is the ultimate fingerprint for those 10 minutes, and this is the past fingerprint, which is it is linking to. So it's fingerprint of the entire time chain of what happened in time. That's how it achieves the time chain. This is the core. Now, as you saw, this is the Merkle tree, root hash of that blockchain, previous hash getting linked. Now, what your wallet does is something else. This is what the miner needs to understand. But what your wallet does, it only cares about transactions. It doesn't need to understand what the block is about, what the hash chain is about, what everything is about. That's the miner infrastructure on the background. You only care as a wallet and an app developer. App developers, wallet only manages the list of outputs in different transactions that it is holding and that it can spend. And as an app developer, you only create to design the transactions and make transactions happen. And that's it. You send the transactions to the miner, miners add it to the block, you get the transaction ID, and transaction ID you can explore on the What's on Chain Explorer that I just shared with you. That is your purpose. And you have very simple API of wallet. Different wallets exist for every blockchain, and they have their own API or SDK that you use to broadcast transaction and receive the transaction ID. And then you can read any transaction as well. Either write a transaction or read a transaction. That's the two things you do. So it's very simple, and you create transactions between different users peer-to-peer. So you create, let's say you have an application with thousands of users. Every user is signing up. So they sign in with their wallet itself. And then the wallet, you make the programming in such a way that they do some button click and some transaction is triggered using the wallet API on the blockchain. And then that user has paid basically peer-to-peer to another user. So for every user, you basically either sign them in with their own wallet or sign them up and created a wallet for them. And then you have the users interact between each other with wallets, wallets to wallets, peer-to-peer between each other. That's how you create a blockchain, decentralized blockchain app. Now the transactions, this is the beauty I was showing you, right? Inputs and outputs. This is the cash system really which is functioning. Now this is different from some blockchains which have come up later, like Ethereum and other systems which are account-based systems. They are not cash-based systems. This is a cash-based system in which you have one note, another coin. All of this is different baskets which are getting unlocked and spent. As then they are spent and saved as outputs. These are called UTXOs, unspent transaction outputs. As we go next, it's the acronym for representing unspent transaction outputs. So basically, you had Bitcoins getting unlocked and spent. They were Bitcoins coming in from previous outputs of previous transaction. Then the Bitcoins are now held in these outputs, new outputs. Now these are unspent. Until the next transaction happens, these are in unspent, right? So the wallet is holding the coins, which is holding the wallets are basically essentially holding the unspent transaction outputs, a list of all the outputs that they can unlock. All the Bitcoins right now are held in these outputs somewhere. In some transaction, output number 1, output number 2, every transaction which is unspent, some transaction outputs will be unspent, not spent right now, not spent as input in another transaction, essentially. So this is what we call a note of cash, essentially. A UTXO is essentially what you can understand in your wallet terminology, a note of cash, which you're holding right now and you're going to spend. You're going to unlock by giving the correct unlocking script, and we're going to unlock it and spend it in the next transaction. When you create an output for someone, you can create the custom information lock instead of doing a standard payment. That's where we go into smart contracts. But first, you need to understand this deeply and securely, that you don't have doubts in this, because any doubts you have at this point, I'll also clear before we dive into the smart contract part of it. So let me just briefly cover. Essentially, overview of the blockchain and the transaction structure is this. You have the block headers of every block in the blockchain. You have the Merkle root in that. The Merkle root has transactions getting hashed and the hash tree, binary tree getting formed, which is called the Merkle root. And there are Merkle paths. Each transaction has their own path that gets you that transaction. This is all higher level stuff. What you are concerned with is designing the transaction, which is where smart contract happens. This transaction has inputs and outputs. This is what you're concerned with. You create as a wallet. Wallet also manages the inputs and outputs, but essentially use the wallet API to create these outputs, these custom outputs. Now, to do a standard payments, you are doing a standard output of paying, let's say, 100 rupee to my friend and 100 rupee or 50 rupee back to me as change. I create an output for myself. Now, wallet of myself recognizes that, okay, I got this output. It is holding the coins and I have the ability to unlock it. So I'm saving it with myself. And next time, whenever I need to send those coins, spend those coins, I'm going to spend them as inputs in another transaction. And I'm going to unlock them with my signature. And then they're going to be spent. Those are payment transactions. They can also be smart contract transaction. In the next phase, I'll tell you that this itself, if you do a custom output in which you write a custom script instead of the standard payment script, that becomes your smart contract. Before this, do you have any doubts? I'll just clear this before I go on to the custom scripts part of it. You can raise your hands if you want to ask anything or discuss anything, which we can discuss right now before we go on. Yes, someone raised their hands.
Kumar, you can go ahead. Paveen Kumar.
Hi Rohan.
Hi, Praveen.
Uh, I have a doubt on how Merkle tails are connected to wallets.
Good question. Merkle tree is held by miners. It's not connected in that way. Merkle paths are held by wallets. So essentially, you have a output in your wallet, right? That okay, I am holding this coins. Now you receive an output from someone else, right? Someone else send you a transaction in which your wallet they send that transaction telling that okay, I have paid you. So your wallet detects that okay, I have got this output. Now my wallet needs to know that this transaction was added to the ledger as well, right? It's not just something that he sends me the data packet of the transaction directly to me. That okay, this is the input, this is the output. I have spent it, but I need to make sure that I put it on chain and it has gone on chain, and the proof for it that it got on chain is that its hash was part of a Merkle path that was timestamped in the correct chain, the time chain, the leading chain. It was hashed, and you have the Merkle path, which is becoming the proof for it. So the wallet also saves the Merkle proof for this transaction. So whenever someone sends me the payment, I send it to the miner. I get the Merkle path or Merkle proof back from the miner for it, and I keep that Merkle proof with me. That and then when I send it to someone else, I send my Merkle proof along with it. That okay, I have the ability to spend it. I'm proving that this is not being spent as of yet, and that's how I prove it. So Merkle paths are what wallets are holding. That's your answer essentially. Merkle path is essentially the list of hashes that link to the root hash for your transaction only, because there will be multiple thousands of transactions, other transactions in the Merkle tree entirely. So only your path is what your wallet is holding, your transaction path.
Hello, Rohan. Can you hear me?
Yeah, I can hear you.
This is me, Shailesh. I had a question to ask you.
Yeah.
Actually, I was supposed to ask you that since in smart contracts, what happens that once we formatted our script, code script, right? So it'll write it to the ledger, and post writing to the ledger, it'll update the history of the transaction, right? So this process is something cannot be reversed, right? Once we
Yes.
write the description, so if we like, let's say for example, if I send you the $20 at a time, right?
Hmm.
Or of mistake, can instead of $10, I sent you like $100, right? But that was out of mistake. But what if I want that transaction to be retrieved or regained, or in order to send you the exact amount that I was supposed to send to, that is exactly the $10 only. So
Hmm.
how do we go about this? If like let's say the process is not reversible in that case.
Yes. Good question. For this, you know what I'll cover is the white paper. Let's say I go to mm, go into the white paper. One second. Yeah. In the Bitcoin white paper, it is mentioned reversible. Yes. See, in the introduction itself, it mentions completely non-reversible transactions are not really possible. What it is talking about is that right now with credit cards and normal payments, you can reverse transactions. And with credit cards, at least you can reverse transaction by blocking your entire card and things happen. This is a lot of difficulty. But at least with this system, we are able to reverse transactions. But you know, with reversing transactions, you are putting a cost on identity. Everyone needs to be KYC'd highly. Your merchant, you need to know. The seller, the who is buying also you need to know, because they are reversible transactions. So merchant has already provided you, let's say, a service, and then you say that okay, I need to take my payment back. And that becomes a cost to the merchant. That's why only reversible transactions possible, in which the ID and verification and all this providing of this facility of mediating the dispute between people, that okay, this is now reversed and everything. This becomes a trust-based model in which some intermediary is coming. And it has inherent weakness and it has a high cost. For small types of payments, for micro payments, You need non-reversible transactions in which you don't have this, you don't care about, okay, 1 cent went or 2 cents went more. Who cares? So for that, you should be at least be able to do payments with almost zero fees on the internet and have the ability to do non-reversible transactions in which you already consume the data. Now you can't tell me that, okay, you didn't consume the data, you want your money back or anything. You consumed it, I gave you access to it, it was atomic. It happened in one go. You gave me this with one hand, I gave you the money with another hand in one go with no trust. We gave both each other. We were across the world, we don't know each other, we don't have anything to do with each other. We just transacted in data and we had a non-reversible transaction happen. So Bitcoin was essentially made to do this. This is to reduce the cost. It becomes almost zero cost to make, and we still have the ability to make non-reversible payments. See, here is written: the cost of mediation increases transaction costs. It increases the transaction fees. That's why we have the percentage fees of credit cards. They're not just earning money for the sake of earning money. They have to provide all the service of mediation and everything between the merchants and everything. That is the minimum practical transaction size and cutting off the possibility for small casual transactions, very small cost. And there is a broader cost in the loss of ability to make non-reversible payments for non-reversible services. So this is also a problem. You will be if you go to the Bitcoin theory course, which is after the Bitcoin basics, you can go into deep dive into every single line of the white paper in the Bitcoin theory course on Bitcoin SV Academy, in which if you go through this now, they will clear everything about how it is about trust and non-reversible transactions and everything. But coming to your question about large payments, when you do large payments, you can also do that with this network. There you need the identity and you need to be able to make non-reversible transactions. For that, you need to write smart contract type of transactions when you need to have multi-signature transactions with escrows in which some time-bound duration is there, that the transaction, until then that person can claim it back. You can write that type of smart contract outputs as well, that they cannot be spent until a moment in time. Though these are time locks are there, that until then it cannot be spent and you can always reverse it back to yourself and spend it yourself. So those type of custom transactions we can create for that. That's how we solve that problem for larger payments. That's a concern only for larger payments, essentially.
Sure. Thank you.
Yeah, I hope that answers your question. Okay, and yes, let's move on. Thank you for your questions. Let's move on to the next phase of smart contract. How do we do that? For that, you need to understand what is a predicate. It's very simple. So Bitcoins are held in these outputs, right? When you spend this output, miner only needs one thing: binary, to validate the transaction, whether you can spend the output or not. So for that, you provide the correct answer, your signature, whatever. So that's a script that you run, that's the answer you provide for it to get unlocked. So Bitcoin baskets are going to get unlocked. So it's a binary deal, whether it's going to get unlocked or not. Now, this is what is done by a predicate. Predicate, you can research in computer science, it's called a logical function that takes any stack of data as input and resolves it to true or false as output. So that's a predicate. So every Bitcoin output is actually a locking script you are writing, creating, which is a question mark, which is a function, which is a predicate, which will be unlocked by the correct stack of data as input. When you try to spend it, you give the correct stack of data as input. You're spending the output, which was the predicate function, which was the script, which was holding the Bitcoin, and it got unlocked and spent. So if you give the wrong answer, it won't be getting spent. And now you can write custom information logs, which are custom functions, which can test for any data to follow certain constraints. That stack of data should come as input, and this output, whichever you created, which is the question mark. Okay, I can even create contracts like someone give me this answer for square root of 4. That is the output I created. A predicate function which takes the input as the answer of square root of 4, and it tests whether it is really a square root of 4 or not. If it is a square root of 4, it will unlock the coins, and that coins can be spent and that person can take his money. And if it is not, then it won't. And also, if there is any error in this script evaluation, miners will not allow it to be spent. So miners essentially just validate these inputs. The scripts, they combine with inputs to the outputs, give these inputs to the function, which was the output, verify it, whether the top item on the stack was true, if it was true, or whether it was non-zero essentially. If it was non-zero on the stack, then the Bitcoin basket output is spent unlocked. So that's how you have the smart contracts. Going further, I won't go very deep into this block serialization. This is the byte level structure of every single block, and but there's a version of the transaction, then the version of the block, then there is one second. We have very less time, so but you can go on the Bitcoin SV wiki and cover this. There's the hash of the previous block, hash of the Merkle root, 32 bytes, 32 bytes. This is entirely the block header structure essentially. The timestamp and the difficulty target for the proof of work for this block, and then the nonce value which the miner is solving. This the entire block header is in this only. It's very simple. Previous block hash, Merkle root, timestamp, the difficulty target, and the nonce value which he was iterating. That's the block header announcement. If he announces the block to the entire network, he's done. It's just 80 bytes. It's just 80 bytes in total. If you see 32, 32, add it up, it's just 80 bytes. Now, if this 80 bytes, this is the block header which every wallet in the whole world needs to keep. 80 bytes per 10 minutes. And every wallet keeps updating their own, it's called a light client, in which you're not keeping every transaction in the whole world. You're keeping only the block headers. You're not even keeping the Merkle roots. You're only keeping the block headers and only the Merkle paths for your own transactions. That's all. If you have this, you have the ultimate decentralization, because the whole world is keeping the time chain. Every wallet in the whole world, embedded IoT devices, are also keeping the time chain. And it's very easy. If you calculate 80 bytes in 10 minutes, in 100 years also, you will get only a few megabytes of block headers added. That's how it is. So it's very easy and it keeps getting added. So now, structure of inputs. I won't go much deeper into it as well, but this is a transaction structure in which transaction ID is of 32 bytes. And then you have the transaction outputs, number of outputs. You are going to select, oh, this is the structure of input, not the actual structure of output. But you can read it on Bitcoin SV wiki. I have less time. I won't go much deeper into it. You have structure of outputs and structure of inputs. And then you have the entire transaction structure. First, let me cover the transaction structure, how it looks really. You have the version of the transaction. You have the number of inputs, right? First, you claim how many number of inputs you're going to give in the transaction. This is the byte level structure of the transaction. Then you have every single input, array of all inputs, which are actually the unlocking scripts. I'll tell you the structure of each input is here. Each input, array of all inputs, then number of outputs, then array of all outputs, and then the lock time. There's a lock time, which you can write different constraints that this transaction cannot be spent till 10 minutes. This is how your answer is also answered. Someone asked, right? How do you irreversible transaction? This is lock time. If you put the lock time as 10 minutes, your transaction won't be able to be spent until 10 minutes. It's still reversible until 10 minutes. And if you can still take it back, and that can happen. So that's essentially how you do things. Then out point is something you need to understand, because this input is referencing a previous output, right? That's called an out point. So a transaction ID output number 2 is going to be referenced by this input. How do you reference it? This is the transaction. This is the structure of the input. Transaction ID which you are unlocking in the previous transaction, which output of that, output number 1, output number 2, whichever output you're unlocking, this together makes the out point. And then you give your unlocking script. The length of the unlocking script first you give, and then you give the actual script, which is called the script sig. And then you give a sequence number. I won't go much deeper into this, but sequence number is also something you can use. You have the ability to use. It's like iterating, negotiating and iterating over the transaction. Sequence number, you can keep iterating the inputs. Also, when you have to write loops in Bitcoin, this is how you write. You keep trying to figure out a loop, the answer. If the loop is figuring out the answer, then the Bitcoin is unlocked. And then it goes to the next, the smart contract is unlocked. But until then, the sequence number keeps going next. And a sequence number also does not need to be on chain. So only the final transaction, the final sequence number with the final transaction goes on chain. Until then, you can keep processing the input and off chain yourself. And this is how the bottleneck of blocking the transaction with a lot of transactions and loops does not come. Ethereum and other blockchains, they have done an account-based structure which creates parallelizability problem, sharding problem, which cannot be sharded. But Bitcoin in a cache-based system, it's shardable, it's horizontally scalable, it's 100% sharded, because these outputs are a cache-based model that can be processed independently. instead of one balance account number, which is iterated sequentially. And also loops can be created in this fashion. Off-chain processing happens, and then on-chain only the answer goes. So this is how the Bitcoin structure works. There's no for loop inside the Bitcoin scripting operation codes. There's a reason for that. Satoshi didn't already thought of it, that there should not be congestion on the network with unpredictability of how much processing time the transaction will take, all that. With the Bitcoin transaction, it's very simple. The transaction size itself tells you how much time it takes you to process it. That's why the transaction fees are also based on the size of the transaction. Per byte, there is a fees of Satoshis. That's why it can be processed by the miners. They can just look at the transaction size and know how much processing it will take. That's very technical. I'll go into it in a later lecture in the sessions I have with you when you really need it. But I'll just briefly tell you the different transaction format types. So as I told you, right, Bitcoin standard payments happen, which are called pay to public key payments, in which there's a standard output script. It's very simple script in which it is just checking the locking script that you write in a standard payment is just check sig. You just write a demand that someone, whoever I'm paying to, give me the signature of this key as the answer to the predicate. If you have that, then the Bitcoin gets unlocked. So whoever you paid to, basically their keys, you wrote the transaction for that, only their 6 signatures unlock the transaction. That's the standard payment, pay to public key. Now there is a pay to public key hash, which is another type of payment. That's also called a standard transaction also. All of these are standard transaction formats. There are 6 types of them actually in total. So pay to public key hash is providing a little more privacy. Instead of the pay to public key revealed in the beginning itself, a hash of the public key is revealed. That is known as the Bitcoin address actually. It is not the public key, but the hash of the public key. That is the Bitcoin address. That is what you pay to. And while the person is unlocking it, that is when they reveal the actual public key. And that is when they give the signature as well. So both of this is tested in this script, pay to public key hash. If I had more time, I would have gone to every single operation code here, but these are operation codes. Okay, this will give, so I'll just tell you a bit more about what the other transaction types are. Essentially, it is multi-signature transactions in which right now you had only one signature unlock the output. You can also have a constraint of 10 signatures required of multi-sig to be unlocking an output, or you can have 2 out of 3 signatures unlocking an output. Like that, you can create escrow systems as well, and you can create some other complex system, a voting system as well for something. This is how the multi-sig works. But then this is not the only constraint. You can even write your own scripts. This was only the standard scripts provided, but now in Bitcoin SV, you can write custom scripts of your own. For that, we have higher level languages like TypeScript. This you won't have to code yourself. Don't worry. This is daunting. This is assembly level code of virtual machine of Bitcoin. This is the final compiled script, which is binary level operation code, assembly level. But you write in a higher level language, you do assert statements which create the conditions on the data that is, okay, this is how you write a predicate. I'll teach you that later on. Zawe, when he'll come, as script founder in the next meeting, he will also take that session. He will be teaching how to write smart contracts very deeply with TypeScript. And that's why I wanted to learn, have you learn about that also. But I want to tell you one thing, which is very important. Go to Bitcoin SV Wiki and spend time. Wiki.bitcoinsv.io. Search for OP codes. OP codes, right? You will get OP codes used in Bitcoin script. So you know there is virtual machines. I'll tell you what virtual machines are. It's very popular. Ethereum virtual machine is there. Java virtual machine is there. Any language which is which has the ability to run on every single processor has a virtual machine. Why did Java become popular than C? Is because of this reason. For C, you need a compiler to compile for every single processor and give a different binary for that processor, for that chip. But if the Java virtual machine, which is a standard virtual machine, is running on your operating system, you install the JVM first to run Java. If Java virtual machine is installed, then you don't need to write the you don't need to give the binary for that, for the processor. You don't need to compile your code for every single processor. You can just compile it for the JVM and give the JVM bytecode to, that's the Java bytecode as the compiled Java output binary to every single app, to every single mobile device wherever Java is installed. That's why also Android uses built on Java. APK is essentially Java compilation. It's running a JVM inside that is giving a standard format for targeting. That's a standard virtual machine. This is also a format that has been made as WebAssembly is another virtual machine on the browser as a standard. It has been made nowadays, which is also a stack machine. Now, Bitcoin also has a virtual machine just like that, which is called the Bitcoin virtual machine. Now, this is also a project in the ecosystem in TSOC as well. Some of the teammates are working on Bitcoin virtual machine standardization and making some libraries to access the virtual machine, just like WASM or WebAssembly virtual machine exists. And there's a library of tools to program and target that virtual machine with compilers. So that is the very deep project in the ecosystem of TSOC as well. So in this Bitcoin virtual machine, you will need to understand this. It's a stack machine. It's very simple. It's based on Forth. It's a beautiful language that existed, which did not become that popular, but is inspired from Forth. It's very much like a WebAssembly stack machine, which is modern stack machine on the browser. It is like the Ethereum, if some folks might be having knowledge of how to code in Solidity. Ethereum virtual machine also exists. There's a bytecode of Ethereum. It is not the way Bitcoin virtual machine is. It's a different structure. It is not a cache-based structure. It is not parallelizable. It's a single-threaded machine, which is account-based. It has different constraints. It has its own programming language, but Bitcoin has more of a different structure than it, which achieves this sharding and parallelizability. But for now, you need to understand this. You can write Solidity contracts for Bitcoin also. You can write TypeScript contracts for Bitcoin also. Why? Because just like you can write code in any language and it compiles, right? This is called higher level languages, which compile to lower level languages. So higher level languages like C, Go, TypeScript, all of this, you can write the code in, and if you have the compiler targeting Bitcoin script, Bitcoin virtual machine, if it supports it, then you can get the Bitcoin binary predicate output of it, and you have the Bitcoin transaction. So just like that, you can have right now in the ecosystem, the most popular language is TypeScript, which many developers also know. So TypeScript is what is getting used popularly, and you can write code in TypeScript itself. You don't even need to learn Solidity. TypeScript is even more popular. So yeah, but there is a Solidity compiler that also exists. It's called Transpiler, which compiles Solidity contracts. One second, transpiler.bitcoinsv.com. It compiles the Solidity contracts also into Bitcoin SV contracts, but it's not as good as writing code in TypeScript yourself, because this transaction structure and the way you can optimize it is deeper if you write it directly in TypeScript. So we recommend that only if you need to write. See, in most of the projects of TSOC, you actually don't need to go deep, dig deep, this deep. It's only for advanced projects or intermediate projects and advanced projects where you have to go dig this deep. So yeah, that's how it is. Now I think that is where we are coming to an end of my technical deep dive into the operation codes and smart contracts of it as well. You can just browse through this operation codes if you want. There is bitwise logic, there is dropping the top stack item, there is rotating the top, duplicating the top stack item, there is data manipulation, splitting the top stack item, there is and or gate bitwise logic. So basically you can have a Turing complete script written, add, supply, subtract, multiplicate, divide, everything, Boolean logic, greater than, equal to, less than, equal to. This is the lower level assembly code. And there comes the cryptographic functions also as the operation codes, which is what is used in the script evaluation of Bitcoin to be unlocked, which is the check sig verify, check multi-sig, hashing any data which came on the stack, rip md hash, different types of hashes. And yeah, that's pretty much it. So yeah, this is the fascinating part of smart contracting that some projects will be getting into. And that brings me to an end. Let me tell you what is going to happen once you also complete the program. Some of you will be selected also for campus ambassador role based on your interests if you want to. And if you want to take on the coordinator role as well in the projects, you'll get the opportunity to be selected as campus ambassadors, representing and creating societies or clubs for blockchain in your own campuses. and taking the vision and mission forward in your own campuses. So thank you so much. And let me give you a brief of what those look like. We are having the conference at the end, right? That is going to be Enterprise Utility Blockchain Summit, the Meta and Developer Conference. You're going to get to present, and that's where it's going to all work out. Thank you so much, guys. Looking forward to you. I'll be connecting with you with your entire team on the project, kicking off your projects. Today itself, many meetings are scheduled. Please do contact your Spocks. Make sure your Spocks are getting in touch with you. They will be contacting you, creating your groups on WhatsApp, and taking the meetings today itself. Around 12 projects are getting kicked off from 1:30 to 5:30. Make sure you are all there in your own slot of 20 minutes with me describing the project for you, your own project. And if not today, you might be having the meeting next few days, kicking off your project. So thank you so much, guys. Any questions you can ask, and we'll begin.
Rohan sir, how are we going to get a project allocated from? Will be like getting it from a mail or Discord server? Where?
So right now, what is happening
My
is
question, I'll answer it.
Please, Rebecca, you take that. Yeah.
Yeah, so guys, we have already assigned, a lot of projects to the ones who have already submitted the status update form, and the roles are visible on Discord itself. But for formal announcement, yeah, I think we will send an email so that all of you are confirmed that y'all have received y'all have been assigned to a project. So don't worry, you'll get the email by end of day or tomorrow morning.
All right. One more question I have. So like we as a team, as an individual, if we talk about, so we'll be working on single, like just the individual project, right, throughout this program. Is it so? So we won't be able to contribute to the like a lot of our main project which we wish in case if we had to have the time. Hello, am I understood?
Yes,
Yeah.
yes, Shailesh, you are.
Okay. So how
Yes.
is this like?
Yes. It's very specific because you see the projects are very deep, and we want to make
Mhm.
sure that the projects come to a completion. That's why if people are distributed and contributing everywhere, you won't have completion of any project. And probably many people will contribute to a single project, and that could be easy projects. We want everyone to be working at your own difficulty level. That's why you're allocated projects. At your own
And,
level, you're allocated project.
and
So
look at the bright side. Okay, continue, Rohan, sorry.
yeah, so if you really have some specific thing that you want to do, so you can shift your project, but you can't contribute to multiple projects. But we do have, after 1 month of contribution, if you are feeling like you want another project, we can consider it. But ideally, we want you to be making sure you go through the program entirely and complete a project as a team, working with your team closely and bonding together with your team.
On the bright side, when you add on your resume, you can proudly proclaim that you have, successfully led to the development of that one project itself at TSOC. So that would be difficult in case you, start contributing to multiple projects. So that is one authenticity that you can, gain out of contributing to one focused project and develop your skill set revolving around it itself.
Yeah, sounds fair. Thank you. See.
All right, Rajashri.
Hello, sir. I wanted to ask that when I was reading, it was written that Bitcoin is a warm database. So I didn't understand that. So can you explain?
Oh, wonderful question. Warm means write once, read many. So immutable databases have this property of warm property, we call it. Because as I told you, the time chain, things are buried in time, right? You can't change what happened in time. The transactions are buried, and then you can't change the past. That's what the property of the blockchain is really about. That was it, what gives it the accountability and immutability properties. By immutability means it cannot be mutated, it cannot be changed. That's what immutable database is about. So that's basically it. You write it once, and then you keep reading it many times. Even when you want to make updates, this is also a constraint for financial transaction regulation is already there, that you need to maintain all the transaction history, previous history of any update that you do to any database. That's why it's better for financial transactions to use immutable databases or warm databases. That's actually international standard in order to force people to use immutable databases or warm databases, where any changes are also recorded. So you can have updates to the ledger with having, okay, this was wrong, this is the update, but the previous entry does not die. So in databases generally which are not worm, what happens is that same data column, etc., is edited and the previous entry is gone. In the ledger, it's not like that. You have a ledger entry, and then updated entry is also there. There's a separate entry on the ledger updating their entry, but all the previous entries are also there. That's what the blockchain is like. It's a worm database.
Okay, thank you. And that's why that example was written of that hacking. Like if they will hack and if they want to delete the log, then it would be transparent and we can see that if there
Yes,
is
that's the biggest problem for the hacker, because the first thing the hacker needs to do is delete the logs.
Okay, thank you.
So they leave the trails. Yes, that's some applications. Some of you might, if you go into security field, yeah, this is what's getting applied. That blockchain getting used for logging and hashing different things. Security goes another level with that. Okay, who else?
Yes, Paris, go ahead.
Yeah. Good afternoon, sir.
Hi.
I literally thank you to all team of the TSOC for this amazing session. And I am a web developer, and I want to learn some blockchain basics so that I can pursue career in it. I guess this type of meeting will be held regularly, and I surely will be come to end of learning these things very well.
Thank you so much, Varis, for your kind words. As we will be proceeding with the sessions in the future, we will be providing more resources as well for blockchain basics. Of course, my sessions are always going to be insightful and guiding you on how you are going to be proceeding with web development, on app development using Bitcoin. Mainly, essentially, you have to be learning. If you want to be very, very productive, focus on learning wallet APIs, how to use wallets, SDKs, and just create transactions, and that's it. And basically, you have to become concerned only with two things. And for a normal app, you need to only create transactions and read transactions. And for a more complex app where smart contracts are involved, you also have to do some TypeScript smart contract written, get the transaction output, and then make the transactions using the wallet. That's pretty much going to be it. We will be sharing with you more courses. Bitcoin basics course, everyone I hope has done. I guess whoever has completed phase 1 has done, who's allocated the projects. Once we go to the next phase, we also go deeper into Bitcoin development. So that's it.
Yeah, one more question. How the projects are allocated? Yeah, I just have completed the first stage, and how I can't able to see where my project is allocated in the Discord server.
Okay, so on the Discord server, your own name has a role attached to it. Rebecca, you can briefly tell you about it. And project section, if you're added to a project, you will have your role besides the contributor, you will have another role for the project name will be attached to it. Your own project name for your own roles, list of roles you have. That is what is going to identify you which project you are in. And with that role, you will be able to access a channel in the project section, the TSOC projects, and that section has that channel where your entire group of teammates are there with that role itself, and they are in that channel having access to the channel. We're not having every channel open to everyone because that will create such a mess in Discord notifications for you guys that it will all be a mess. So we have focus channels for you guys to be interacting with each other, and your point of contacts will also be interacting with you there itself.
Yes, exactly what Rohan said. So yeah, the assigning, I mean, we're still assigning projects. We have completed almost 400, I mean, we have completed assigning almost 400 contributors. And as and when you are filling up the, forms, we are assigning more contributors to every project. And with the program managers on board, the process is even faster. So don't worry, guys, you all will be assigned to a project. Like I can assure you that from our end.
Thank you.
It's in your role name.
I'll make a video tutorial to help you how to go about all that. So there'll be a separate channel just near recordings called video guides, and I'll basically be explaining how you can see that. And also you'll get an email with the project mentioned, with the project name mentioned, and the POC that will be managing you throughout the program. Yes.
All right. Yes, Parth.
Actually, Hi, am I audible?
Yes, you're audible. Go on.
Actually, I just wanted to ask one question. Is it possible that as the all the programs and the projects are not yet kickoffs like started, so is there any chance that I can still get into another project because mine project is the BDFC, and which is I guess very difficult for me. I guess it will be very difficult for me to understand as I'm in my first year and I only know the front end part. I can contribute in the Web2 clone, and I can contribute in that in more a better way. So is there any way that I can still change the project?
Yes, there is. We certainly understand. We are trying our best to do the allocations, but of course we can go wrong also. So please raise a request
Raise a
on
ticket.
Yeah, I
raise a
have.
ticket.
Okay. I have just DM the Rikraba, but yeah, I will raise the ticket as well.
Yeah, better to raise a ticket. Don't be
Yeah,
DMing. It's like just issues like this. Better to raise a ticket because we can have a more formal process of handling, and anyone can handle.
sure,
Not
sure,
doesn't put a
sure.
pressure only on Rebecca. Okay,
Thank you so much.
thank you. All right. Anyone else? Rajeshi, I think you can put your hands down if you already asked the question. Anything else? No, you don't need to ask.
So I
Yeah.
have to ask that we have to change the our username and write contributor and then the project name which we have been allocated.
No,
It's
no, no,
not
no, no. You don't have to change your username.
not
Keep your
necessity. Yeah.
the
If you
role is
want,
attached to it. Yeah. Please,
if
Rebecca.
you want, you can just do it. Like I have nicely written my name as Rebecca, program manager. So you can just it's like just a formality. If you want, you can do it. If you don't want, it's fine because we have contributors with very weird names on Discord. So no worries. The team already has, the Discord usernames and we'll be navigating to it. No worries about that. And you all have the roles, right? Your colors are also visible that orange is contributor. So it's clearly evident that you are a contributor.
Okay.
Yeah. So you don't need to. Kevin. Oh.
Hello, Rohan.
Yes. Hi, Kevin.
I have a question about I haven't received any project assigned to my ID. When will I assign to the projects?
Kevin, don't
Have you
worry.
completed the phase one?
Sorry.
Have you completed the certification course?
Yes,
Bitcoin
I have completed and uploaded to the Google Forms.
form. Okay. I think that will be handled. Rebecca, what's the status? We can just check of Kevin.
They must have submitted recently, like today or yesterday night. So that those are yet to be taken up.
All right, Kevin. If you have just submitted it recently, 1 or 2 days, it will be allocated in at least one day. It will be allocated. Don't worry,
Okay,
it will be allocated. Yeah.
Okay, Roshan. Thanks.
Let's have this. Let's have this. If your project is not
Yeah.
allocated till Tuesday at most, then you can raise tickets that your project.
100 people have completed in yesterday evening and today morning. So we'll assign those. Don't worry.
Okay. Anyone else? Shailesh, yes.
No,
Or
actually, I wanted to say.
yeah.
Uh, Actually, I wanted to say that I've been fill filled the form I think a week ago only, but I've not been allowed in the project yet. So I was just trying to tell Rebecca ma'am to please do it in case she's telling that she's done with the 100 people already. So I was ensuring if I was in that list or not because I've not been allotted yet.
Yes, Rebecca, please. We need to look into this wherever we
Yeah,
are.
he has been assigned Bitcoin swipe widget already.
Shailesh, you will have to notice. You must not have got an email. Right now, we haven't sent the emails formally of each project allocation. So you would have only got the allocation on Discord. A
Yeah,
user
on
role
Discord.
name is there and will give you access to the channel, the Bitcoin swipe widget for your case.
Okay, but I've not got any notification yet. So in order to just get it
There's no
confirmed.
notification. When you get a label on your role, you won't get a notification. It's just a label which is attached along with the contributor. Just check your profile. And you must have been added to a channel also called Bitcoin Swipe Widget.
Okay, let me get checked.
Yeah, that's the answer for everyone who is confused on that side. Ishani, yes.
Yeah, it was same. I also completed a week ago, and I'm still not allotted to any projects or
Okay.
team.
I think the role must already be there then, the same answer on Discord.
No, it's not there yet. I
Rebecca,
checked
could you
few
check
times.
Ishani?
Yes,
Okay, I'll
I've been added to that channel which you mentioned right now. So yeah, I think I'm in.
Oh, so just be mindful about what is happening on Discord. Just don't, repeat the same issue on loop because it's very irritating. We're just a small team of 10 people and we are managing 1,000 contributors. So just
Thank you.
be mindful of.
Sorry for this thing. I'll
Okay, it's okay.
channel.
All right, Arpit.
Uh,
Arpit, you can go on.
Yeah, she's also been assigned.
Hi. I have been allocated a project, but the tech stacks are not visible on the website.
Oh, that's some tech stacks are remaining. Which project is it?
Zero knowledge marketplace.
Yes, because some projects also require you to go through the research phase of it with your team and come up with the tech stacks yourself. So that's also why.
Okay, thank you.
Yeah.
I'll release a formal Excel sheet with all the details about the project because our website is still yet to be updated with all the new editions that we have had in the project list. So yeah,
Yes.
I'll put it in the announcement. I'll put it in the announcement. Announcement sounds like a good channel.
Thank you.
All right, guys. Thank you so much. Point of contacts will be connecting with you and we'll be having the sessions of Project Kickoff. And looking forward to work with you over the 3 months. And this is where we really begin. Hats off to you guys. Bye. Thank you so much.
Thank you. Bye.